Hi students, I'm Neeraj Bansal and welcome back to the Math Navigator. Today we are diving deep into the past paper of AIHL3, May 2021, time zone 1, right? Have been struggling with these questions of finding yourself stuck on the methods. Remember our golden rule here. Stop guessing, start navigating. I'm going to show you the exact logic the examiners are looking for so you can secure those top marks, right? Before we jump onto the paper, a quick heads up. If you need personalized help to crush your upcoming exams, I offer one-to-one session. My contact number is right there in the description below. Feel free to reach out and let's navigate into the paper, right? So as you can see in the heading itself, it is May 2021 AIHL paper 3. So paper 3 students and even teachers are finding it quite difficult, right? So there is my pro tip for you if you want to do well with these papers, right? What is that? Right. So this is pro tip. Most important thing in solving the paper 3 is do not stuck on one question and give equal time to both the questions. You know that in AIHL paper 3 you have two questions, right? And the time given is 1 hour 15 minutes. Do not just go and stuck on one question, because what happens, there are several parts. In the beginning the parts are easier and then it's getting tougher and tougher. So give equal time to both the questions. Even when you are not finished with question 1, go to question 2 and then start doing it. And the most important thing is start visualizing math. That means understand the situation, what is happening there. Got it? So let's start. Let's not waste our time and start doing paper 3. So this is my paper 3, right? So first we'll try to understand what the question is saying and then we'll move forward, right? It's very important to understand the question. Got it? Right. So let's start doing the question. So what the question is saying, a suitable site for the landing of a spacecraft on the planet Mars is identified at point A. The shortest time from sunrise to sunset at point A must be found. Radians should be used throughout this question. All values given in the question should be treated as exact. Mars completes a full orbit of the Sun in 669. So I'll highlight the important point. 669 Martian days. That means if you see this, this is Mars and this is revolving around the Sun in 669 days, or rather 669 Martian days. Doesn't make it. Then on day T, where T is an element of Z, the length of time in hours from the start of the Martian day until sunrise at point A can be modeled by a function R. So this is modeled by a trigonometric function A sine beta plus C. T is an element of R. So what is happening from here? This is the diagram which is given to us. So this is like the whole 669 days. What is happening in 669 days? And this thing shows that time taken from start of the day, that means start to sunrise, right? The time taken is RT, right? The time is in R. That means let's say in this is the summer, so time taken is maximum. Again here the time taken is minimum from the start of the day till the sunrise. Got it? So this is what my question is saying. Now let's start doing the question. So it is saying show that B is equal to 0.00939. We know that RT, so I'm doing A part of it. RT is equal to A, A sine dt plus C. So as per this, BT is my time period, which is equal to 2 pi, and B times T669 is equal to pi over 669, which will be B is equal to, sorry, it comes here, then, right? So B is equal to 2 pi by 669, pi by 69. Let's check with our calculators what is happening, right? So let's say pi. So, and here is my pi, and then I'll do this, 5669, enter. I should control. So 0.009392 is 0.0093, right? So what it was asking, we have to prove this, right? Perfect. So we are correct. All right. Let's move to question part B. Find the Mars completes one rotation in 24 hours and 40 minutes. Find the angle through which Mars rotates in its axis each hour. So I'll use ratio method. You can use either ratio method or unitary method. What it says is time for one rotation is 24 hours and 40 minutes. So 24 plus 40 minutes, which is 40 over 60. So these many hours. If I'll calculate on my calculator, I will get 24 plus 40 over 60. So 4 plus 40. So 74 over 3. Let me leave it here. 70. So this is 74 over 3. So 74 over 3 is equal to 2 pi. I'm making the ratios. 74 over 3 times pi equal to 1 over x, because I want to find it in 1 hour. So x is equal to 3 times, here I should write 3. So 3 times pi by 74. Let's calculate. 6 pi by 74. 6 pi 0.2547. It is coming x is, so we are good with this, right? So let's move to the next part. Let's do. The time of sunrise on Mars depends on the angle delta at which it will tilt towards the sun. During this Martian air lambda varies from this to this, right? So minimum for C minimum equal to negative 0.44 and max is equal to 0.40. The angle omega through which Mars rotates on its axis start of the Martian year day to the moment of sunrise at point A is given by cos omega delta, right? So we are given the relationship cos omega is equal to 0.839 tan delta, right? So show the maximum value of omega is 1.98. So I have to take the minimum as well as the maximum. So cos omega, so omega is equal to cos inverse 0.839 and can be negative 0.440, or it can be cos inverse 0.839 tan 0.440. We'll check both the values and let's see what happens. Yes. So let's take our calculators. 0. Cos inverse cos inverse 0.89 and tan 0.44 is right, and then we place and go like 8 2. Right. So 1.1647. So this is coming right. Now let's check this. Just copy it. This is negative. So negative here. Enter. 1.97685. And so here it is. My answer is this. Because this greater value and we have to it. This is my answer. So the maximum value of omega is 1.98, which is that. Find the minimum value of omega. So minimum value of omega is this. Great. Perfect. Now this is question. Now we come to part D. Little trickier I find. Choose your answer in part B and C to find the maximum value of RT. What was my B? So B was the time 0.2547. So right. So basically what does this mean? In 1 hour it is taking this much angle and the maximum angle is this much. So hours or maximum hours or time is equal to 1.97685 divide 0.254, which will give me so let's say nine six eight enter. So 7.761 maximum. Now let's move to three part to minimum values. This has to be done in the same manner, no difference. So minimum, here my minimum was minimum is 1.1647 divide 0.57. Let's get the value. 4.57. Got it? So this is how we will do. Show that A is equal to 1.6 correct to two significant figures. So we know our formula, which is RT equal to A sine theta plus T, right? RT A sine theta plus, perfect. So now I have the maximum value it, which is this, minimum value of it, which is this, right? So this function is maximum when this term is 1. So I'll write RT max is equal to A plus C, right? And Rn equal to minus A plus C. So now our R max is 7.761 equal to A plus C, and RT min equal to 573 equal to negative A. Now you can go directly, we can go directly to the equation solve. Let's say A is equal to X and C is equal to Y. Menu, can go to algebra and then solve equation, equations variable, right? So now I have to put in my equation 7.761 equal to x plus y, right? And here 4.57 equal to negative x plus y. That's it. So a is equal to this we are doing a is equal to 1.594 and 6.167. Right? Okay. E. So we have done E part. Now let's move the F part. Find the value of C. So C also we have found. F part C. Perfect. Right. Let's move to the next. So let's move. Now this is saying let ST be the length of time in hours from the start of the Martian day until sunset at point A on day T. So basically we have start of day, then we have sunrise, and then we have sunset. So from start sunset, the function is st, which is given by 1.5 sine 0.0099 t plus 283 plus 18.65, right? So this time is from here to here. And LT, the length between the sunrise and sunset. So from sunrise to sunset is given by LT, is 1.5 sine 0.0093 t plus 0.83 negative 1.6 0.939 plus t. Very good. Got it? Now we have to find the value of d. So from here to start to sunrise, my function was given by where is my function? R is equal to where we have. So from here we got the value of A and C. So A and C, right? And we've got RT is equal to RT is equal to 1.592 sine B dt. So B was 0.00939 T plus C. C was given as 6.15998. So basically I can see this time, this from sunset start to sunrise is from start to sunset minus sunset to sunset. So basically this means RT is equal to ST minus LT, right? So if you sub it in the values, we can straight away write D is equal to 18.65 minus 6.15998, which is equal to 12.49. Here, right? So this is my answer. Why? Because if you do ST minus LT, that means this function minus this function, you will left with 18.65 minus. I have not written the whole thing first to be 2. That's the only. Got it? So perfect. We have found the value of D. Now there is another question. It is saying FT is equal to this and LT is equal to this, right? FT can be written in the form imaginary part of Z1 minus Z2, where Z1 and Z2 are complex numbers in the form of T, right? So it is an imaginary part. Imaginary part. Now if you go back to complex number, it can be written as R cos. This you have done in complex number. R cis theta, right? So which can be written as R of cos theta plus I sin theta. This I sin theta, in this R cos theta plus R I R sin theta. So IR sin theta R cos theta plus IR sin. In this case, if you see, this represent imaginary part and this represent real part. So I'm saying, according to this, H1, the imaginary part is given by Z1 minus Z2, right? So this can be written as Z1 minus, so FT can be written as Z1 minus Z2. So if Z1 minus Z2 is my FT, so this means 1.5 sine of 0.0939 plus 2.83, right? Yes. And 1.5 sine 0.0920, take it from 9 plus 283. This becomes one complex number, and this becomes 0.3 to give me 1.5. Says, or in complex form I can write I 0.00939 plus 0.86. This is my argument. 1.6 raised to the 93. Basically, what does this mean? These are two complex numbers. This complex number becomes Z1. And this becomes Z2. My Z1 is equal to 1.5 by 99 plus 2.83, and my Z2 becomes 1.6 e raised to the power of 0.0. Basically, we know r cis theta can be written as in complex in Euler's form or exponential form as REI theta. Here theta is my argument and r is the modulus or mag. For this, you can check my video on complex number, right? I'll make it so. So we are done with this, right? So r is equal to, r can be written in the form of z1 minus z2. So this will become imaginary, and then you can write this 1.5 sum 1.5 raised to 5 plus 6 I so 0 9. Got it? So we are done with the first part of H. Let's move to the second. Let's see what the second part is saying. Right? Let's see what my second. Hence or otherwise write an equation the form of this is right. So we have to write it in the form this form, right? So we have to write a function in this. So we have got this ft, and we know lt is equal to ft plus d. I'll write it. Lt equal to ft plus d. So first we'll sort out ft. So my ft is naturally part of, and we have to write it in of 1.5 by nine plus 83 minus 1 point. Right. So I can write this as z1 minus z2 as 1.5 I times e raised to the power of pi 83 minus 1.6 e raised to the power pi 9. Got it? Now I can write z1 minus z2 equal to, now I take this as e I point to 939. Take it as common, left with 1.5 by 0.83, 1.6. That's it, right? Now by 0.0939. Now I can solve this complex number. I can solve. Let's take my calculator. I write 1.5 and then raised to the power of I. So I'll not write I from here. I use this I. E raised to the power I 0.83. Right? Minus 1.6. Hit enter. Right. So I've got this. But I can see this is the Cartesian form. Right? So I've got this answer 3.0277 plus 0.459862i. Got it? Now I have to convert this into exponential form. How will I do that? I have menu, then I have number, then I have complex number tools. Then I have to convert to polar, right? And I have to put my cursor in this number, complex number tool. So menu. Then I need to go to number, complex number tool, then convert to polar, place cursor. And so this will give me 3.0649 by 0.00939 t times e raised to, so I'll write plus here, 0.99086. Perfect. So I can write it as 3.06249 cis, then this is my angle 0.0939 t plus 2.99086. So this is my Z1 minus Z2. So now if I'll see, it has R cis, so cos component will finish because this is the imaginary part only. So I have to take the imaginary part of Z1 minus Z2, which is 3.06249 sine 0.00939 t plus 0.99086. I need to take only the this is the, see, this is the whole complex number. This is the complex number with the real as well as imaginary part, and this is the complex number with only real part. Only real, sorry, only imaginary part. Got it? And so my LT was FT plus P. So my FT is 3.06249 sine of 0.00939 t plus 2.99086 plus d, and d I will already have found from the previous questions. Where is my d? 12.4. So plus 12 point. So this is my answer for part. I know this is a little difficult, but if you go to the complex numbers and do it nicely, then you'll be able to. So H2 is done. Let's move to H3. H, I'm doing H third part. Let's see what it is saying. H third part is saying find in hours the shortest time from sunrise to sunset at the point A that is predicted by this model. So that means predicted by this model. So time is predicted by this model. So for the, we have to find the maximum or the minimum. Shortest time. So for shortest time, the sign thing, the value will be minimum. The value will be minimum when sine theta is equal to negative. Therefore, shortest time equal to negative 3.06249 plus 12 point. Let's calculate 12 minus 3.6 9.47. This is my answer. Got it? Oof, this was so long, right? I can understand. See, paper 3 is difficult. We are done with question 1. Have to continuously practice. And still, if you find any doubt, you can contact me on the number given below and we'll be in touch, right? So please subscribe to my channel.